Hello, viewers, and welcome to our webinar with Kaiko Systems titled Getting Competitive Advantage from Better Deck and Ballast Tank Maintenance Aided by Digital Technology. Our guest speakers from Kaiko Systems today are Taz Bachu, Vice President of Global Sales, and Nick Vaughan, Vice President of Success. Both will be bringing you a presentation where you can leave questions for them in the Q&A section of your screen. Here's Carl Jeffrey, founding editor of Digital Ship, to explain more.
So we're going to look today at how we can use advanced digital technology to better manage deck and tank maintenance, and how we can get a competitive advantage if we can do it better. Now, we may find ourselves thinking much more about maintenance over the coming years, particularly if we work with older ships. DNV said last week that safety incidents had increased 42% between 2018 and 2024. That's particularly with fires and explosions. And this can, of course, relate to badly managed maintenance. And one of the biggest problems in managing ship maintenance is working with complex inspection data. And our company presenting today, Kaiko Systems, has developed standardized ways to gather inspection data relating to maintenance. So this includes giving seafarers special mobile devices with software to gather data and take photographs. And once the inspection data is in standard formats, we can do more modeling with it, such as to track and predict corrosion. And we can get a better overview of what needs to be done. So this way, crew can be gathering maintenance-related data continuously, and we're not just waiting for periodic surveys. And the commercial advantage comes from having less unplanned outages, being able to plan dry dock work more efficiently, and getting fewer observations in the inspections. Kaiko Systems has only been in business for 5 years, but already its software is on 1,100 ships. Its customers include OSN Home, Reederei F-Lays, TMS Cardiff Gas, and Columbia Ship Management. Our speakers today are Nick Vaughan, Head of Maritime with Kaiko and a former surveyor with Lloyd's Register, and Taz Bachu, Vice President of Global Sales. We're going to have a presentation of about 30 minutes, including some slides and a demonstration. Then we'll take your questions. So I'd like to invite Nick and Taz to start the talk.
Thanks, Carl. I'm just going to share my screen and get the presentation queued up. So, really good to be back on a Digital Ship webinar, and this is a little bit of a preamble before we get into the technical element of our presentation today. So really what we're going to talk about is a little bit more about on the industry trends, a little bit more about what's happening within the market right now, and really kind of ensuring that we have a good understanding before we actually look at how Kaiko Systems can actually help and has helped over 1,100 vessels really revolutionize how they actually manage and deal with their technical frontline operations on board their vessels. So if you look at those broader industry trends, these are kind of shaping how we think and look at deck and tank maintenance, and it's more critical than ever. Carl mentioned in his introduction that over the past decade, we've seen significant changes in the operational and regulatory environment for shipping. But in parallel, we've also seen that worrying rise in incidents, especially on older vessels. And he mentioned a DNV report that kind of identified that between 2018 and 2024, safety incidents increased by 42%. Now, this increase is most severe in older ships, and we do have some data to show you about that. But the high proportion of those incidents have been traced back to inadequate maintenance. Now, this points to a larger trend, which is structural fatigue. Now, this is not just a life cycle issue, it's what I would call a risk multiplier. The data that DNV presented shows that vessels that show signs of fatigue are significantly more likely to be involved in incidents. In other words, poor maintenance isn't just a cost center from now on, it's a safety hazard. If we look at the data and we look at the world fleets by year of build, what we can kind of note from this information here is that the remainder of the 2020s will be marked by a global merchant fleet that will get older and older. Something charterers, operators, and owners will have to accept as the new normal, especially if demolition volumes remain as muted as they have been in the past few years. A substantial portion of the vessels on being used today will be over 20 years old in the coming years. And in the bulker segment, nearly 30% of the current fleet, both in terms of vessels and deadweight tonnage, will be over 20 years old by 2030. The tanker fleet is also experiencing a similar aging process. Approximately 48% of today's tanker fleet in deadweight tonnage terms will be over 21 years old in 2030, and the container and gas fleets are not immune to this aging trend either. In the gas carrier segment, approximately 42% of the fleet will be over 21 years old in 2030, and by 2030, 49% of today's container fleet in terms of vessels and tonnage will be over 21 years old as well. So what this is really kind of highlighting is that the problem is here. It's not something that we need to safeguard against. It's not something that we need to kind of protect against right now. It's a problem that we have to deal with. And as mentioned, this is going to be an increasingly growing cost center for a number of ship managers and ship operators going forwards. Nick, I know that you wanted to kind of talk a little bit more about the specifics when it came to the kind of the findings from that DNV report, but also some of the trends that we're seeing, in particular in hull inspections, incidents, and safety deficiencies on vessels as well.
Yeah, sure. Thanks, Taz. And I think as you highlighted, the clear issue here is the kind of global aging of the fleet and across all different segments and sectors as well. And this is being driven by a number of different reasons, whether it's geopolitical factors currently, longer ton mileage, the current freight rates, and also the kind of uncertainty with decarbonisation and future fuel options. It means that the current fleet is being run for longer and is therefore aging. And really interesting to see a DNV technical news publication that came out in March this year that clearly highlighted a kind of a trend in the increase in corrosion findings on actually younger ships. So the assumption has always been that with PSPC coating requirements, that coatings were ultimately better and would last for longer, with a kind of minimum life of 15 years. But actually, as we can see from the DNV report, there's a large number of corrosion findings happening both in vessels aged 6 to 10 years. So we're looking at between the first and second special survey. And, we can see a large uptick in 11 to 15 years. So after that second special survey, so vessels over 10 years old. And it's not a linear process, as you can see here. And it affects the areas in a number of different ways. But ultimately, when we combine the aging fleet on the one hand, plus the higher occurrence of these corrosion-related issues in younger vessels, ultimately it kind of highlights the critical issue that we're facing here, and also the fact that additional steps need to be taken in order to manage this effectively, and ultimately reduce out-of-budget expenses or additional downtime that result from these kind of issues on the vessels. And I think that this graph kind of compounds this issue, or kind of shows how the effect can be increased in severity, because there's obviously a clear correlation here between the temperature and the rate of corrosion. And obviously, as the temperature increases, as we can see, that rate of corrosion quite rapidly increases as well. Now, there's multiple factors that influence the extent of corrosion. But when we look at this temperature impact in particular and think about the location of these ballast tanks on board the vessel, whether it's on tankers next to heated cargo tanks, next to fuel tanks, or even the underdeck areas where we have the vessels operating in hot environments, ultimately you end up with a very, very high temperature within the tanks on these coated surfaces, which ultimately can vastly and rapidly accelerate corrosion. So again, when we think back to the aging fleet, and also in combination with the impacts of corrosion at younger ages, combined with these increased rate of corrosion with increased temperature, again, it just goes to show that we need to really be inspecting the tanks more thoroughly, having a better understanding of the condition. And ultimately, if this isn't done, we then start to see these effects of corrosion So what we're looking at here on the left-hand side is, a loss of structural integrity. So we can see that the corrosion leads to a thickness reduction, both at the local level and at the general level. So we can see domino cracking here on the left-hand side, and then also grooving, which can ultimately lead to cracking and leakage. And this can really not only impact kind of the coated surfaces, the structural integrity of the tank, but also ultimately, most catastrophically could lead to leakage from ballast tanks into whether it's cargo tanks, fuel tanks, etc., which can obviously compound the issues on board. And if we look at the right-hand side here, we can also have a huge impact on the maintenance and operation costs. So we can see here the coating condition after 2 years where there was a poor coating application. And obviously, when we think of the life cycle of these vessels with the PSPC coating regime, obviously you have these idealized conditions at the new build state, when the vessel's in the yard, the block painting and preparation. But ultimately, once the vessel goes into service, it's very hard to keep these conditions that would be required. So ultimately, where repairs are done on the fly or maintenance is carried out, and if it's done poorly, ultimately you can end up with not only high additional costs to complete this maintenance or additional work, but then ultimately the effectiveness is very low. So again, you end up with coating breakdown, you end up with accelerated corrosion, and then you end up in this spiral again where additional maintenance and work is required to try and improve or repair the coatings again.
Thanks, Nick. And a recent report by McKinsey and Company on maritime digitization noted that more than 60% of shipping companies are investing in technologies to improve asset lifecycle management, but many struggle with that fragmented data set that they get from their current way of doing inspections and surveys. And this is perhaps where our focus comes in today. How do we move from fragmented manual processes to something that is more continuous and to some elements predictive? At Kaiko Systems, we've approached this by standardizing how inspection data is gathered. Our mobile-enabled systems allow seafarers to collect maintenance data in real time using a digital twin that is often accessed by a mobile device, that's a phone or a tablet. The seafarer is then able to take photos, create or compile structured reports through pre-loaded checklists, and also we're able to kind of leverage that metadata to provide some location tagged records to ensure that the inspections and the maintenance is taking place. This then turns everyday inspections into usable data that can be analysed by the shore team and the team on board the vessel through a cloud-based dashboard. Now, taking this one step further, we can now model issues like corrosion across the ship's life cycle. We can identify risk trends, and we can plan proactively to minimize those risks and to minimize that cost center that will be creeping up in the next decade or so. This turns what once was periodic surveys on legacy-based software, think Excel templates, Word templates, legacy ERP systems, into this kind of concept of continuous insights and a real-time understanding of your vessel and your fleet's maintenance needs. The results speak for themselves. An ABS survey in 2022 showed that ships using predictive maintenance reduced unplanned downtime by 30% and were able to actually optimize dry dock planning by 25%. They're not theoretical statistics, they are actual bottom line gains. One of the things that Kaiko Systems has enabled our users to do and is enabling the maritime industry to do is operate with a real-time competitive advantage, but also unlock real commercial advantages. Using a tool like Kaiko Systems to collate all of your data, analyze that data centrally, and apply artificial intelligence and various data models to that data means that you're unlocking real commercial advantages. There are fewer surprise repairs, there is better dry dock scheduling, there are fewer inspection observations or findings, but most importantly, this is a much more efficient use of your crew's time, and you're able to enable your workforce to really focus on the things that work, on ensuring that the vessel is serviceable. We've spoken very briefly just about kind of a broader kind of industry insight into why this is important right now, what the impact is on an aging fleet, but also what the commercial impact could be. I'm now going to hand over to Nick, who's going to run through a technical demo showing you how some of our customers, some of our users have used this in practice and some of the benefits they have gleaned from that. Over to you, Nick.
Brilliant. Thanks, Taz. So I think the first thing to say here is it's not all doom and gloom. So we focused a lot here on kind of what the issues are and why these are only going to increase. And now we'd like to run you through, how we can work effectively with a system like Kaiko to manage both this inspection and maintenance regime and ultimately give you a competitive advantage. So as Taz highlighted, we have multiple components to the system, and I want to show you both. So give you kind of an end-to-end demo so you can really understand the whole process of how this would work both on board with the crew and shoreside with your superintendents. So I'll start on the dashboard side. So this is our web-based dashboard. Hopefully you can now see, and this is exactly what your superintendents, fleet manager, technical director would be using in the office. So this is the starting point to have that overview of all of the vessels in the fleet and the jumping in point to really drill down to the condition of a vessel, a component, and really see how things are changing over time. So here we can see a demo vessel that we've set up for this webinar. And I think it's important to state here how this process works. So what you see before you is a vessel that we've set up in our system. And this is set up specifically with the ship's plans. So in this case, you can see the representation with the GA plan on the screen combined with the ship's procedures. So with the company procedures from the SMS. The combination of these two gives you a ship-specific setup. And in our vessel health map here, you can clearly see the results of the inspections in the context of the location on board the vessel. So within this webinar, we're talking mainly about deck maintenance and also ballast tank maintenance. So as you can see here, we've set those up on a vessel and we set this up in a standardized, structured way. So it's set up specifically for each vessel. Here we're looking at a tanker, but we can set up any vessel type in the system. So we have, a broad range of different tankers set up, likewise gas carriers, and across the dry bulk segment, containers, car carriers, etc. So every vessel is set up specifically based on the ship's arrangement and equipment in combination with your company's procedures. So it's set up very specifically. And as I mentioned here on the VHM, you have that location context with these inspections. And we can see here, it's very clearly color coded. So from the shore side, whether that's 1,000 miles away from the vessel, you can have a very clear picture of not only the condition of your vessel, but also the status of the inspections as well, to really understand how these inspections are being completed. Are they being completed on time? And ultimately, what are the results that are coming from on board the vessel? And the aim here is to bring that whole static process from your SMS to life and really enable you to understand the condition of your vessels and then make decisions based on those to ensure that your vessels, maintain operational uptime, and also you can plan more effectively for these key events within the vessel's life cycle, like dry docking, and have an advanced preparation for what needs to be done when you're in the dry dock. So here we can see an overview of the condition of these results. And we can clearly see here with a very simple system, traffic light system of green, orange, red, fair, good, fair, poor, mimicking that commonly understood industry categorization, the condition of any element of the vessel. So here we can see the main deck has been broken down in a structured way into elements that can be inspected by the crew. And in a minute, I'll show you how that works on the vessel when the crew complete these inspections. But we can see here clearly the results of not only the main deck inspection, but also for the ballast tank inspections that have been completed on board. So this is your overview. And then the idea here is that this is the jumping in point. This is where you can understand the condition, dig into things in more detail to ultimately understand what actions need to be taken and plan effectively. And we have a number of AI tools to assist you with that. So there's a huge amount of data that's generated on board. You can start with your summary. And then from here, whether we're looking at the ballast tank inspections, so we can see here for any inspection item, we can see all of the detail that has been reported on board. So we can expand this. We can see here, as is common for ballast tank inspections, very dark spaces. It's actually hard to see the condition And obviously, where the crew have spent the time to do these inspections, we want to ensure that you in the office can still get the maximum insights from these pictures. And that's why we've introduced something called Kaiko within our system. So, we can see with the image that's been submitted, it's quite hard to really see the condition of the tank. But by enhancing the image using our Kaiko AI assistance, it's much easier then here to see the actual condition for yourself and identify any potential issues that may have been kind of not possible to see in the darkened image. And we can do this across the ballast tank inspections, which really enables you to gain the most insights from any one of these inspections. At the same time, we have an AI-assisted rating. So again, we're generating thousands of data points from the vessel. And the expectation here is that the shore team aren't looking through each of these kind of individually, but we can also assist your shore team. So have an AI technical assistant that can also give not only an AI rating, but it can also do automated corrosion analysis as well. And this can be run automatically across any of the data points submitted from the vessels in your fleet. What this enables you to do is to really garner the relevant insights from the vessel without being overwhelmed by a huge amount of data that's being produced by the vessel. And if we jump across now to maybe look at the main deck maintenance, again, this is a high risk area. Whether we look at from class surveys as well, there's always a high occurrence of issues on the deck, because it's accessible, but also because of the nature of the environment. So there's always a high level of coating breakdown on the main deck and corrosion, and ultimately these items are the ones that get easily detected when a third-party inspector comes on board. And again, using our system, it's very easy to structure your inspections of the main deck in a standardized way so that the crew complete these inspections and then have this full overview for yourself, right down to the level of each individual area that's been inspected. And again, further empower and assist you here with the corrosion analysis. So again, the system can automatically detect any areas of corrosion or coating breakdown and highlight these areas at an individual level as well. So we can see at both the vessel's global level, which I can show you, and also an individual inspection level. And ultimately, this enables you to identify any potential problem areas on board the vessel. So again, instead of having to check each item individually, at the highest level of the vessel, as you can see here, we could compare crew rating. We can also compare the AI assisted rating. In this case, actually rated with a higher rating than the crew, which gives you that objective viewpoint as well, or the comparison of both to show you effectively the worst rating, to really enable your shore team to understand where they need to look further. And we can also do the same with the corrosion analysis. So again, this is something that we've developed internally. We've trained our model based on the information that's been submitted from those 1,100 vessels in our fleet to really understand how we can more effectively detect corrosion on board the vessels. And the first step that we've worked on is just corrosion detection. Now, with that combined with object identification, allows us to then build the model into something that can also understand and determine the extent of corrosion on board at a much more global level. So that's something that we will also include as the model progresses and further we develop these assistance tools. It's also worth pointing out that, having all of the information in front of you is obviously very useful, but it's really a focus on the issues on board. So again, having that summary of the findings to really understand where are the problem areas, where does my attention need to lie, and where do I then need to take action to ensure that these either don't develop further or cause issues, where repairs would need to be made outside the docking cycle. So we can see for any individual finding, we have a full summary of what's been reported again, and we then have the ability to have that follow-up process within the tool. So again, removing any of this communication that comes via email, back and forth between the ship and the shore team, centralize that within the system, within the context of the issue that's been reported. And it's then very easy now to manage these effectively. So we can set deadlines. So in other words, when the action needs to be taken and followed up by the crew, and then have a very simple communication back and forth, not only with the vessel, but also internally with the shore team as well. So this is fully transparent for everyone to see the latest status. In this case, we can see here and instructions be given to carry out chipping and painting as an example on these areas to prevent further coating breakdown or further corrosion. And we can see Again, I'll show you shortly in the mobile application how the crew can then follow up on these to ensure that these issues are actioned effectively on board, followed up, and again, that full transparency internally so everyone can see the latest status, the condition, and then really make sure that these issues don't escalate. What I'd like to do quickly now is to jump across and show you the other side of the system. So we've kind of spent the last few minutes looking at the shore side of things and showing how the data is represented and how you can really make actionable insights or take actionable insights from this data. What we'll do is now jump across to the app side of things to show how this data is collected on board and how you can structure these inspections across your fleet. So again, we take the same model that's been set up, so the vessel-specific model, and this enables the crew on an individual vessel, but ultimately across all the vessels in your fleet, to carry out these structured inspections in a standardized way. So we can see the same representation of the vessel based on the structure that's been defined using the vessel's plans, such as the GA capacity plan, etc. And we can see for any area on board the vessel, we have a very structured inspection. So in this case, if we're carrying out a main deck inspection, it's very easy for the crew to then go to the relevant area of the vessel. We also guide the crew through these inspections. So we can have positioning diagrams, additional text to really explain in terms of what needs to be done or any specific items that need to be checked. So they can understand where they need to be, what they need to inspect. Ultimately, the way we think about this is having, your most experienced or best chief officer on board every vessel to guide the crew through these inspections. And then they can always see the previous inspection results. So both the rating and also the example picture. So again, really understand for themselves what was the condition last time the inspection was done. Has it changed? Are there any issues that weren't there before that maybe we need to follow up on? And then a key element here is that the photos are taken live on the device. So I'm running this on a tablet here. It runs on a tablet. Mobile phone fundamentally runs offline. So the crew can really take this with them anywhere they go on board the vessel, and they carry out the inspection live. So in this case, I'm in the office here. We can take a picture of the relevant area of the vessel. Pictures are taken live within the system. So let's make sure you have the actual condition of the vessel at the time. We can take detailed pictures as well. So if they really want to capture specific items or issues on board, they can capture as many detailed pictures as they want. And once they've captured the condition of the vessel, they then can be guided through a rating. So again, this is part of that process to standardize the inspections, remove that level of subjectivity from the crew. So again, this can be aligned with your company's procedures or your SMS, and allows the crew very easily to complete a standardized reporting. And also when we look at the tags underneath, specifically collect any information in a standardized way. In this way, it's very easy for them to complete these inspections area by area, understand the condition, how it's changed, complete the relevant inspection on board, supported by photographs, and complete standardized reporting in line with your company procedures. Again, removing that level of subjectivity. And as I mentioned, all of this is running offline, so the crew are really taking the device with them wherever they go on board the vessel. In the case of tankers or where you need intrinsically safe devices, you can run this on an intrinsically safe tablet like the IS 930.1, such as the OCIMF Side 2 inspectors are using. And this really enables and empowers the crew to complete these inspections in a structured way, in a standardized way, collecting all of the relevant data at source. And just at the end of the inspection, so when they've completed that deck inspection or the ballast tank inspection, very simple to go back to the accommodation, connect to the vessel's Wi-Fi. We can see all the data that's been cached offline. And then it's very easy to upload this data directly to the cloud, notifying the shore team of a new inspection that's been uploaded. And then as you saw before within the web-based dashboard, very easy to log in, have that overview of the latest status of any of these areas on board the vessel. So hopefully that gives you an overview of the end-to-end process, both shipside using the mobile application to carry out the inspections on board in a standard way, but also how you could use our web-based dashboard to have that 1,000-foot view of the fleet, understand the condition of a specific vessel, understand the issues that are there on board the vessel, and then take actions accordingly to manage those issues, ultimately ensuring that you minimize the kind of out of budget expenses. So you have an informed picture of the vessel condition prior to things like dry docking. So you can do that preparation in advance, or really understanding from the elements of main deck inspection, maybe where you need to instruct the crew to complete maintenance or even put a riding squad on board and do that in a timely, planned way so that you minimize kind of these additional expenses or ultimately minimize any downtime that might result from unexpected issues on board the vessel.
Awesome. Thanks, Nick. Just going to reshare my screen. So what we've kind of seen here is that Kaiko Systems really kind of presents a new way to capture, collate, analyze, and ultimately make decisions using the data that you are capturing through your day-to-day operations. And I think the overriding kind of message and conclusion is that using the legacy software and those unstructured templates to monitor and track maintenance is a practice of the last decade. If we look back at all of the information we've presented today, the current status of the global fleet is aging. It's been recognized by organizations like McKinsey, like DNV, like ABB, that there are a number of incidents and infractions caused by a lack of adherence to proper maintenance, to following proper safety procedures, and to conducting those proper maintenance checks on board your vessels. Nick, we've spoken a little bit about kind of the current status, what the projected status is, but what's kind of the vision for Kaiko Systems going forwards, and certainly in the immediate to short term, how are we kind of driving our product development?
Yeah, I think that's a great segue. So ultimately, where we've started, like right now, and the foundation is building the structured data set. So as we mentioned, setting up your vessels in a standardized way to ensure that all of the vessels in your fleet complete these inspections on time, in line with your procedures, collecting all of the data in a standardized, structured way, removing that level of subjectivity from, individual crew members or individual vessels. And that foundation of data allows you to then build on top of that. So we have a number of different themes, as you can see in front of you on the slide. So one of the elements as we call closing the loop, and this is more focused on those kind of regulatory regimes with third-party inspections. So again, what we have on the screen is side 2 right ship, pre-PSC, could also be your class inspections as well. Really understanding the preparation that's required for these inspections, but then ultimately following up on the post-inspection analysis, fleet-wide review, and really continuous improvement. So understanding what was the preparation status, what was the ultimate results, how do we improve continuously, make sure that those issues don't occur in the future. When we look at having that standardized data set across the fleet, we can really then look at AI that works for you. So as I mentioned, we've already developed our own in-house corrosion detection algorithm. This has been trained on our data set, and this is something that we will further build on and further extend. So we already have corrosion analysis, we have an AI-powered vessel summary, we have our image enhancement, as you've seen, but this is really just the starting point. And the standardized data set within the system allows us to build and use these tools on top of that ultimately further extend kind of like the reach or what's capable and what your shore team can do. Because I think if you speak to any shipping company, you realize they run very lean. There's not any additional personnel ship side or shore side. So this is not talking about replacement of people or removing people. This is really talking about extending what people can do, improving their efficiency. And that's why we're looking at now developing our own in-house AI technical assistant. So again, imagining that every superintendent, every fleet manager has a technical assistant that's already looked at all of the data submitted from the vessels, also looking specifically at relevant use cases for coating and steel repair. So as I mentioned, moving kind of forward from just detecting corrosion to really understanding what's the extent of it on the relevant objects on board, and then being able to quantify, for instance, extent of coating repairs required, or quantifying steel repairs that might be required at special survey or when you're in a docking, and then ultimately embedding this within the system so it runs across all of the elements of the system. And the third pillar, or the third area of development, is in terms of analytics. So again, building on that individual vessel structure, having that standardized data model with, for instance, the VHM vessel health map visualization that I showed you earlier, but enabling you to then utilize that across the full fleet. So having that go-to vessel data set, giving multiple stakeholders visibility. So again, we already have a charterer access. So you as a technical manager can be using the system, not only drive efficiency throughout your operations, but also externally where you need to share that data with third parties, such as your charterer. That can ultimately be done within the system, removing again these additional reports and emails, etc. So automate that reporting and data sharing, and ultimately give a 360-degree view of the vessel. So have that standardized data set that's validated at source and allow that data to be shared with relevant third parties, both on the kind of commercial operational side, but also maybe on the regulatory and inspection side as well, with the third parties that, periodically come on board the vessel to complete their inspections as well.
Amazing, thanks, Nick. And I think it's really exciting that we're building on that foundation and really kind of looking at that process of continuous improvement and continuous maintenance as well, so that organizations can begin to evolve with Kaiko systems as well. That concludes our presentation. Thank you very much for listening. I will now hand back over to Carl for questions.
Well, thank you very much, Taz. Well, we've got 4 very interesting questions so far, so I guess we'll take them in the order they came in. So first we're going to Rostock in Germany. Kathleen Kloon, her LinkedIn says she's maritime consultant doing a audit and a former superintendent nautical operations with AIDA Cruises, but she's asking about the relationship with class. So does the system need an approval? I mean, presumably class are doing their own surveys separate to this. They don't just accept your data, but is that something maybe for Nick, since you know class?
Yeah, sure. No, a great question. So maybe it's easier to say, what we're not, to give that kind of element. Like, we are not a PMS system, so we are not focused on that core of machinery inspection, running hours, time-based maintenance that requires class approval, ultimately following kind of an audit trail side of things. That's really where I think, when we look at the title of this webinar, really looking at driving efficiencies or getting kind of a commercial edge. That's really our focus. So looking at these other areas of inspection, which are required in the SMS, but often currently exist in Excel sheets, Word reports, etc., enabling you to standardize that, build that data set, and ultimately kind of remove those elements of legacy tools. So no, it doesn't require a class or flag approval. As we look forward into the future, particularly at building that standardized data set, that might be something that's required going forward, but in the current kind of setup and state, that's not something that's needed.
Oh, very good. Okay, so now we're going back to London. So Takis Markatos is General Manager of Liris Maritime, which is in Clerkenwell, so quite close to you in Hatton Garden, Taz. So you did answer quite a few of these questions after he posted them, but oh, there's quite a few. What is the cost? You probably don't want to answer that. How easy is it to set the system up on a handheld device? Does the ship model need to be entered in some way, or is it a simple case of scanning the general arrangements and other plans? What happens if the AI enhancement of the dark photos misses something or gets it wrong? Don't know where you want to start with. About 5 different questions there.
Yeah, lots. I think it'll be a bit of ping pong between Nick and I. So Takis, thanks for your question. We are incredibly close. So let's catch up after this, and I can run through pricing with you face to face over a coffee.
Very good.
In terms of kind of setting up the system, so the system itself is device agnostic. So I often use kind of Nick and I as an example in this. Nick is very much an Android man. I'm very much an Apple iOS man. The application works on both, but it also works on explosion-proof handhelds for tanker and gas ships. We've deployed now. Rough figures are probably 50% of our fleet are tankers and need to use explosion-proof handhelds. So we can deploy on those very, very easily. The application itself is a progressive web application, so it doesn't need a download from a specific app store. Setup is very, very simple, and it's accessed through a website, which our success team will take you through. In terms of kind of ship models, scanning general arrangements, etc., I'm going to hand over to the man that does that day in, day out, so I'll let Nick answer that bit.
Yeah, another great question. So this is in terms of the actual setup and building that data model and the standardized setup. That's something that we do in-house. So we have a team of ex-seafarers and ex-superintendents, and we set up this as part of the managed service. So we have a standardized data set that we request from the technical manager requiring vessel plans, etc. And then we set this up specifically for each individual vessel in line with your company procedures. So we have a template process to make this more efficient, make it faster. So we can generally set up vessels in days. We're not talking about the kind of months required to set up some of the PMS systems and enter the data. It's really a very fast turnaround to get this operationally live on board your vessels as fast as possible. And I think in terms of the latter part of your question, with the AI enhancement of dark photos or an inaccurate description, this is something that we are continuously improving, right? And I think something that's key to point out is, humans are not infallible either. It's very easy for a human to miss something. The idea here is to provide an additional set of eyes, an additional set of insights, as it were. So, where we look at these ballast tank inspections with, hundreds of data points being collected, the idea is that the AI can already assess these and give you some additional insights. It might be possible that something's missed. Also, it's possible that a human will miss something, but the idea is to provide you that additional data set, an additional set of eyes on everything, and ultimately, with the combination of AI plus a human, ensure that none of these things are missed.
Oh, very good. So now we're going to Croatia. So another multiple section question. Andre Raguzin is Sales and Application Support Manager at Softhelm. So first, how do you model the vessel's data in terms of assets and components? Is there a standardized framework for calculating asset? Oh, the second question is a standardized framework for calculating asset health indices and managing risk. Third question, are you doing methodologies like failure mode and effect analysis? And fifth, I think you kind of answered this. What role do you see AI playing in improving and optimizing maintenance? Oh, maintenance strategies. You didn't talk about maintenance strategies actually, but don't know where you want to start with those.
Yeah, I'll try and tackle all of those. Lots of great questions there. So yeah, I mean, we have a standardized data structure that we use for each individual vessel. That's something that we've built up over time in conjunction with our customers as well, as we mentioned, for the various different vessel types. So the idea is that there is a standardized data set that gives you comparison not only across your fleet, but can also allow you to benchmark or compare kind of globally as well. The asset health indices, so we have two elements there. We have the crew reported. So as we saw in the app, the guided rating, to try and remove that subjectivity from the crew rating. But then we also have our own AI assessed rating as well for each data point that's submitted based on a criteria. So you always have that comparison. We don't use FMEA in the system at the moment. I talked a bit earlier about kind of where we see the further development of AI. But I think actually that's almost the next step, which is, optimizing these maintenance strategies, because currently everything is largely time-based in terms of when things need to be inspected. And I think that, for a long time, the industry's talked about the next step beyond time-based inspection or time-based maintenance. And I think building the standardized data set using AI tools actually makes the kind of progress to the next step and actually optimizing your maintenance strategy more effective. And that doesn't necessarily mean that everything gets inspected or maintained less. It actually probably means that some areas might require more inspection or maintenance, other areas may require less, but it's actually tailored to based on the actual condition and the actual trend and change in the condition of those items or assets.
I think just to bounce off that as well. So, Andre, you mentioned kind of the decision-making processes. I think the application as it is now is enhancing that tenfold. And to use kind of real-world examples, we've heard from a number of superintendents that work with Kaiko systems already that the ability to kind of go into the dashboard and see images very clearly, have that kind of solid ship-to-shore communication, means that there isn't the need for them to actually travel to the vessel to inspect the component parts or the element of deck plating or the element of that kind of ballast tank that is being inspected themselves. They can actually get the information they need to make a good decision from the crew in real time. So what we're seeing actually right now is that kind of cut in data to real-time decision making. And I think with, as Nick mentioned, with kind of the advances in AI, with the advances in the platform over the next 3 to 6 months, we're actually going to find that the platform moves more into that decision-making realm, but also allows the shore team to proactively manage risk. And cost is a significant factor, but also going forwards, cost is going to be a significant risk in the operation of aged vessels as well.
Well, very good. So yeah, Arvind Sharma is with a Mediterranean shipping company in Switzerland, and combining his question with all about gathering data with Mohammed Hassan. So Mohammed Hassan is saying it's very difficult to take pictures inside the tanks. For real-time analysis, you have to plan. You're going to have fixed cameras on board. We've also done articles about drone imagery inside tanks. Arvind is asking how are you validating the data? Otherwise, it's garbage in, garbage out. So I guess perhaps the most important question of all, isn't it?
Yeah. There's a number of different ways that we validate the data. So one is actually using the metadata. So understanding, when the app's being used, we collect a large amount of metadata in terms of what's being done on board, time taken, distance traveled. That enables us to actually validate the kind of the inspection as a whole. And also, as we mentioned with these AI tools, doing the validation of the images as well to really understand like the quality of the area that's being inspected, but also the quality of the images as well, and provide that feedback loop. So, where the crew have done these very extensive and time-consuming inspections, because I think let's not forget with the ballast tank, it's not like you just jump in, run around, take the photos and get out. You've got to open all the tanks, you've got to ventilate them, do the gas analysis, etc., do your risk assessment. This is ultimately a very time-consuming process. So the idea here is to ensure that when those inspections are completed, that the results are actually meaningful and useful. So data validation, both of the background metadata and of the images themselves, is critical and very key. And I think just to touch on the point about fixed cameras, and Carl, as you mentioned, drones. So fixed cameras, no. Actually, one of our kind of key tenets with the system is ease of implementation, which is why we went mobile first, system agnostic. There's not a massive, or there's almost no CapEx expenditure. You just need a mobile phone or tablet on board, and then the system can be implemented completely remotely. We don't need to visit the vessel, and ultimately that makes it not only cheaper but faster to implement the system as well. Particularly where we look at these aging vessels, where maybe owners don't necessarily want to spend lots of additional CapEx costs to really kind of implement new systems. And I think where you touched on drones, that's something that's super interesting for us. And as I mentioned, we've developed our own in-house AI corrosion detection. And I think as we look forward into the future at combining different data sources, this is something that we're already talking about with one of our customers. The combination of the crew on board inspections happening on the mobile device, combining that with also any drone inspections, particularly for those hard to access or critical areas, but ultimately running that through our AI tools as well. So you get additional levels of oversight and insight that we can provide.
Oh, very good. So Paul Lohner is Vice President Digital with Greek Star in Bergen, and also spoke at our Oslo event last week. So he's asking, are we integrating with other systems such as HSEQ or plan maintenance? And separately, any comment on the accuracy of the AI prediction? And do you have a roadmap to find other points of interest in the images other than corrosion? There we go. 3 questions there. So.
Yeah. Okay, 3 great questions. So the first part with the other PMS, ERP, safety systems, the answer is yes, we do integrate, and we have integrated with a number of different systems, including Hanseatic's Cloud Fleet Manager and Certica. We often do this by a case-by-case basis with our customers, really dependent on the use case that they have and where the data needs to be stored. From our side, we are cloud-based with an open API, so it's very easy for us to push or have that data pulled into other systems. But it really depends on like what needs to be there, because a lot of these systems have been built in a way where ultimately it's just for kind of audit purposes. So there's a question about what data actually needs to go there. Next part, in terms of the accuracy of the AI predictions, coming from a technical background, I was also initially skeptical and have been very pleasantly surprised. And this has been confirmed and validated by a number of our users, both superintendents, technical directors, fleet managers. And as I mentioned, this is something that's continuously improving. So we are continually training the algorithms based on feedback to constantly improve the accuracy, both of the corrosion detection, of the rating, of the summary, etc. And the roadmap, this is something that's really driven by our customer needs. That's why we started with corrosion detection first, because this was the key area of concern that people had. But also now where we look at, for instance, cargo hold inspections, maybe more on the commercial side. Now we're also looking at the kind of cleanliness assessments as well, where this has, potential impacts on vessels being accepted to load certain cargoes like grains, etc. So again, driven by critical customer needs, then allows us to kind of implement those and develop those within our system.
Wow, very good. We've got about 7 questions and 7 minutes, I think, so might need
Quick fire.
Yeah, but Kathleen Kuhn back in Rostock, have you have a predefined inspection procedure, such as, you haven't mentioned mooring line inspection, but presumably this would also work. I don't know if you've got time to give an overview of your predefined inspection procedure, but
Yes, the short answer is yes. So the platform is very flexible in that regard. We have also had requests from mooring line inspections from a number of our different customers. So that is something that's, we're aware of, and it's kind of in our future roadmap. But fundamentally, what we have now is kind of, if we think about what we showed today, we call this hull and equipment inspections. So structural inspections, thinking about eyes on board the vessel. We can do full safety inspections of LSA and FFE in line with, SOLAS and MSC requirements. We can digitize any of a company's procedures where we think more about the forms or checklists that are completed on board and the output in terms of reports that need to be generated, pre-vetting inspections in line with OCIP SIRE 2 requirements and RightShip's RASQ 3.1, and a full port or pre-port state control module as well, in line with port-specific requirements based on the risk profile of those ports.
Oh, so Shubham Johar is a software engineer in India. Is this a training tool mainly using past inspection trends to view how the system is helping? What KPIs are you using, or is it just corrosion analysis? I suppose that's all the modeling stuff you showed. I think that's sort of the answer to that, isn't it?
Yeah, so ultimately, the whole idea here is to use the trends to understand how things are changing. But that fundamentally starts with building the standardized data set and having these routine inspections completed over a period of time. So now with a number of our customers where we've been implemented, and if we think about ballast tanks maybe only being inspected once a year, we're starting to build up that kind of third or fourth cycle of inspections, which allows us to start to build the insights based on the past results, but also see the trend analysis. How's the condition changing? Is that in line with what would be expected? Are they going to, as it were, get to the next dry docking or 5-yearly retrofit or refit, or does action need to be taken prior to that? And when we look at the training side of things, I mean, that's kind of fundamental in our system, is moving away from this computer-based training. As we showed with the guidance, and I mentioned sort of having your best chief officer on board, the idea is to empower any crew member to complete the best inspection that they can with the relevant guidance, move away from a computer-based training or just a library of information that's kind of on the ship's bridge or ship's office, which is really very little use to you if you're stood in the bottom of a ballast tank completing an inspection.
I think just to bounce off that, what's really important is the standardization of data. So enabling the crew to actually ensure that the data is standardized across your fleet is really key here in order to make those decisions, but also to get to that kind of concept of kind of continuous maintenance. And I think the other point to note there in terms of that standardization of data is the maritime industry is set to be 100,000 less crew members by the end of 2026. There is a real skill shortage and a real labor shortage on the horizon with this industry. So ensuring that you have those tools in place to standardize that data set is more imperative now than ever before.
Oh, very good. So now we're going to Kerala. So Ramakrishnan is Assistant General Manager, also in Health, Safety, Environment Quality with Executive Ship Management. Does your model also predict when the next inspection should be carried out based on the photos? He's talking about the rate of corrosion expected in the next few years. So we're sticking with the modeling.
Yeah, no, that's exactly the kind of thing that we're working towards. So as I mentioned, collecting the standardized data sets, seeing how the trends change, and then ultimately moving away from this time-based inspection to actual condition-based inspection.
Oh, very good. So Jobin Matthew is a prevention officer in UK. He's suggesting a helmet-mounted AI-enabled camera. So I guess you get good data. You still got to have the crew member personally inside the ballast tank, which we're trying to get away from. But I guess that's
Yeah.
another way to do it, isn't it? Yeah.
Yeah, interesting insight. This is actually something we tried when we first developed Kaiko and implemented, having a helmet-mounted camera. I would say that there are a couple of limitations with this. Primarily, the one up until now, although this is changing, is the bandwidth and the level of connectivity on board. So our system runs offline. It's designed to run light on any device on board. The crew won't necessarily be using the latest iPhone with terabytes of storage and the best chipset. So we built a kind of a very lightweight application that could run on any device. So we have to think about device storage on board, but also transmission from ship to shore. Because again, whilst we see more and more vessels rolling out, higher bandwidth connectivity, I'm not going to mention any particular providers. There's a spectrum of them available now. A lot of vessels still do operate on lower bandwidth, even using fleet broadband still. So we really built the system in a lightweight way where it's easy to transmit data, which is why we implemented the system initially with photos and inbuilt compression. But where we are seeing higher bandwidth, we do see the option and opportunity to implement videos. So that is something that we've already released within our system. Although at the same time, I would say one limitation currently is, if someone takes a 20-minute video of walking around a tank, ultimately, is someone going to sit shoreside and watch that, or do we assess that separately? So I think these are the things that we have videos within the system. We're understanding how it's being used and what insights could be gained, because ultimately, we don't want shore teams to be sat there for hours on end watching ballast tank inspections, thinking, oh no, they actually missed that bit. It's really about trying to understand how we can automatically assess that to give relevant insights.
Oh, very good. Arvind Sharma from MSC, he's commenting on the previous discussion, which I've forgotten what his last question was, but he's talking about how you're validating the data, monitoring how much time people are spending in the tanks, and getting an idea of the quality and accuracy of the data, because it's very important. Yeah.
It's one of the things. Go ahead, Nick. Go.
No, sorry, I'll very briefly say, yes. So we have the full location of the vessel set up. We can understand the profile. So who is actually doing the inspection, when it was reported, even to the minute data of between the different data points. And you can look at this in two ways. And ultimately, this depends on the technical manager and their organization. Are you using this to understand, what was done on board? Was it done correctly? Or are you using this to understand, hey, we trust our crews, we trust it's being done, and this gives us the ability to quantify, well, how much time does this take? Because I think as an industry as a whole, there's very much this reaction if there's a problem, implement a new checklist, a new process on board without any real understanding or appreciation of the additional time and burden of work that's required. And actually using tools like Kaiko actually for the first time enables you to really understand, well, how long do these things take? Is this the same across all of my vessels? Is it different on board? What's the optimal way to do this?
And I think just to add to that, we get that from the metadata from the mobile device. So that is fed through automatically. There's no additional work. There's no additional configuration. You get that purely by using Kaiko systems.
Oh, very good. Well, we've got about 2 minutes left. I'm just thinking about the drone inspection. If you can automate the whole thing and no people having to go inside the tanks at all, that'd be even more fantastic. Companies could just monitor it all and make it all automated. I saw, Taz, your invitation for coffee was accepted from the general manager of Liros Maritime. So I don't know if you want to take 30 seconds each. Have any final words?
No, thank you very much for having us on the webinar. I think obviously preparing for this and doing the research and going into a bit of a deep dive was more of an eye-opener for me. I understand that the global fleet is aging, but I didn't realize how rapidly and how quick the industry would need to change. So I think it's really quite key to ensure that we're doing the right thing now to safeguard fleets for the next kind of 5 to 10 years, but also to ensure that our crews are not inundated by unnecessary or additional maintenance that could have been picked up through the routine checks. So a really good insight, and really enjoyed the discussion toward the end as well. So thank you all for asking questions.
Oh, Nick, you any last words?
Maybe just to say, as it was evident in the questions, there's no shortage of ideas of what people want to do. And I think always where we started saying, okay, let's build the standardized data set across your vessels, across your fleet, because that gives you the ability to build on top of that, So that for us is really the fundamental element. That's what we can do immediately right away, already kind of empower that with additional AI tools. And I think really the kind of what will come in the future will further not only improve the life of the seafarers on board, but also vastly improve the life of the superintendents and shore teams, enabling them to really focus more effectively on the areas where they can add value, remove a lot of this kind of routine administrative day-to-day stuff, and then ultimately, improve the efficiency and quality of any fleet.
Well, that's fantastic. Well, thank you very much. I shall pass back to Farah for the closing words. Cheers. She's not there. Oh, she is.
Thank you to Taz Bachu, Nick Vaughan, our sponsors Kaiko Systems, and our audience. If you missed our Q&A session or have further questions, we'll be sending you contact details soon, along with a link to this video on our YouTube channel, which you can subscribe for. Join us later this month on the 26th of June for our webinar with Syrico. Visit our website to register. In the meantime, don't forget to fill in our survey, which should be appearing on your screen shortly. And we'll see you soon.
Oh, bye-bye. Oh.